Hello friends, welcome to Susan and John MathTube. This is lesson number 1 in beta gamma functions or beta gamma integrals. And as always, before we start, the most important question and of course the 5 important points. And I hope you are following the 5 points. So let's start. Okay, so look at this. In your syllabus, you learn properties of definite integral, and then you learn improper integral, and then you learn differentiation under the integral sign. These are 3 powerful topics which enhances your integration power. And then comes 2 more topics, that is reduction formula and the beta gamma functions or the beta gamma integrals. And the aim of these 2 topics are somewhat similar. Yeah, the application of integration which you learn in mathematics. Look at this. When you try to find the area, the length, the volume, the surface area, many times you will be forced to use these 5 topics. Similarly, when you learn your engineering applications in other subjects, then also you will be able to, or you will be forced to use the 5 topics. Anyway, I will tell you one very important thing which we are going to do with the beta gamma functions in application of integration is, we use this to find integral 0 to pi by 2 sine to the power nx, or integral 0 to pi by 2 cos to the power nx, and of course integral 0 to pi by 2 sine to the power nx and cos to the power nx dx very fast. Of course, you can use reduction formula or this beta gamma to evaluate these things. Okay, anyway, with that, let's start. So as I mentioned before, beta gamma functions are basically 2 integrals, and I'm going to use the letters m and n to define the integral, and it's given by integral 0 to 1 x power m minus 1 times 1 minus x power n minus 1 dx, where m and n are positive. Remember, I did not use the word integer, I just said positive. So basically m and n stands for any positive number. Okay, so this is called the beta function. And then comes another integral, an improper integral, that is gamma n. And it is given by, it is type 1 improper integral, given by integral 0 to infinity e to the power minus x to the power n minus 1 dx. Again, I am telling you n is a positive quantity. And these are named after the mathematician Euler. E-U-L-E-R is the spelling, but you have to pronounce O-I-L-E-R. So I will repeat once more. He is a French mathematician, Leonhard Euler. He is also called the father of a subject called graph theory. Anyway, these are called the first Eulerian integral and the second Eulerian integral. Anyway, the most popular and common name is beta integral and gamma integral, or beta function and the gamma function. So, look at this. I want you to write this somewhere very neatly. We need this. Okay, now look at this. There are a lot of properties associated with this beta and gamma. Anyway, I'm not going to prove all those things. If you want, you can prove that, and you can check any book you like and you'll find all the proofs there. And in case you are not able to understand the proof, you can email me. But since they don't ask the proof in the exam, I will just mention the properties. So you can write very important properties. And property number 1, beta mn is the same as beta nm. Okay, I'll give a rough idea how this works. What is beta mn? Isn't it an integral? Yeah. Integral 0 to 1 x power m minus 1 1 minus x the whole power n minus 1 dx. But we learned a very useful property long back. Integral 0 to a f of x dx is the same as integral 0 to a f of a minus x dx. I'm sure you know this property. So what I do is I'm going to replace this x with the upper limit minus x. So I'm going to write the second property. Gamma n is equal to n minus 1 gamma n minus 1. The proof comes from reduction formula. Actually, this gamma n is something like we write in the reduction formula. And when you apply the reduction formula, you get this. Or when you try to evaluate this in, you end up like this. If you want, you can try it. I'll repeat once more. Normally, they don't ask proof for the exam. But some of you will be interested, and to be honest, if you're a student who aims for 100% mark, you should never leave anything in the syllabus. So it's better that you study the proof. Yeah, okay. Now comes the third point that is very important. Gamma n is equal to n minus 1 factorial. What? Yeah, it's exactly. But wait a minute. Here n is simply a positive quantity. And here I am going to write n belongs to positive integers. So remember, there is a huge difference between the first one and second one. Suppose you have gamma 10. Then you must write the answer 9 factorial because 10 is a positive integer. Suppose you want gamma 25. You should write 24 factorial. And suppose you want gamma 7. You should write 6 factorial. At the same time, if you have something like gamma 7 by 2, this formula cannot be applied for this situation. So you will be using the reduction formula and slowly moving downstairs. And you will understand the word moving downstairs if you watch the video on reduction formula. Okay, now let's go for the next property. That is property number 4. Gamma 1, 1 is actually positive integer. 1 minus 1 is 0 factorial, and 0 factorial is defined to be 1. And now comes extra important. So please write and please note it. If you want, you can take a screenshot and save it or take a printout. Point number 5. Beta mn is equal to gamma m gamma n the whole divided by gamma m plus n. If you are interested in the proof, please ask. But property wise, this is one of the most important property because this connects the beta integral with the gamma integral. It's a transformation. It transforms beta integral into the gamma integral in a way. Okay, and then comes another property, number 6. Gamma m gamma 1 minus m is equal to pi by sine m pi. Now don't worry about it. It will be maybe in lesson number 5 or 6 I will explain this property properly. Okay, now comes the superheroes. I have to call them superheroes because this is exactly what you are going to use in this semester and in the next semester and maybe even in the third semester whenever you get something in the form 0 to pi by 2. Okay, first of all you have to understand integral 0 to pi by 2 sine to the power p theta and integral 0 to pi by 2 cos to the power p theta d theta are the same. It's nothing but applying the property of that 0 to f of x dx, because sin 90 minus theta will be cos theta. And this is nothing but 1 by 2 beta 1 p plus 1 by 2 comma 1 by 2. And here comes the last one, that is 0 to pi by 2 sin to the power p theta cos to the power q theta d theta will be 1 by 2 beta p plus 1 by 2 q plus 1 by 2. That's it. So I hope you have written all these properties somewhere, and let's start. The first thing I'm going to teach you is how to evaluate gamma values. Suppose we have gamma 10. I already showed you the property. If you have an integer, you have to write 10 minus 1 factorial. You can do this in your mind and use a calculator later on. Suppose you have gamma 7 by 2. Now look at this. Many times you may get gamma 7 by 2, gamma 11 by 2, etc. So what we do is we use the general property, the reduction formula for gamma. That is gamma n equal to n minus 1 gamma n minus 1. If you use this, by the way, what is 7 by 2 minus 1? Think about it. 5 by 2. So what happens is you will get 7 by 2 minus 1 gamma 7 by 2 minus 1, and that gives me 5 by 2 gamma 5 by 2. Again you will apply 5 by 2 times, you apply the reduction formula, 5 by 2 minus 1 gamma 5 by 2 minus 1, and that becomes 5 by 2 into 3 by 2 into gamma 3 by 2. And again you apply 5 by 2 into 3 by 2 into 3 by 2 minus 1 gamma 3 by 2 minus 1, and that is 5 by 2 into 3 by 2 into 1 by 2 gamma 1 by 2. That means eventually you will reach gamma 1 by 2. And let's add that in our list. Gamma 1 by 2 is equal to root pi. Okay, so you can add this here. Gamma 1 by 2 equal to root pi, and that will be 5 into 3 into 1 by 2 into 2 into 2 into root pi. That's it. But I don't like this method. I'll give you a shortcut. Suppose you want gamma 11 by 2. All you have to do is you have to reduce this number by 1. So you get 9 by 2. Again reduce this number by 1. So 7 by 2, 5 by 2, 3 by 2, and as I promised, you will reach 1 by 2 for sure, because this is a fraction with denominator 2 and you are subtracting 1. And at this point you put root pi and use the calculator, simplify. Now once more, gamma 9 by 2. What is 9 by 2 minus 1? Yeah, 7 by 2 into 5 by 2 into 3 by 2 into 1 by 2 root pi. Finished. Suppose you want gamma 3 by 2. That's very easy. 1 by 2. Oh, you already reached 1 by 2. Put root pi. Okay. So I hope you understood how to evaluate this. Now the second thing we are going to do in today's video is we learn how to evaluate 0 to pi by 2 sine to the power 3 theta cos to the power 4 theta d theta. I'll show you the property. Actually the one I told the most important, the connection between beta and gamma. So what we do is, first of all we express this in beta function, because we already have this thing, and the second thing is the connection between beta and gamma. So I'm going to combine everything. So we get 1 by 2 beta, 3 plus 1. What is 3 plus 1? 4 by 2. 4 plus 1. That is 5 by 2. That will be 1 by 2 beta, 2 comma 5 by 2. Now I told you beta is connected with gamma. So gamma m, gamma n by gamma m plus n. and that is nothing but 1 by 2 gamma m gamma n by gamma 9 by 2, isn't it? So the answer will be 1 by 2, and gamma 2 is 1 factorial, and gamma 5 by 2 means 3 by 2 into 1 by 2 into root pi. The whole divided by 7 by 2 into 5 by 2 into 3 by 2 into 1 by 2 into root pi. So cancel everything, and that's your homework. Okay, let's try once more. Suppose I want to evaluate integral 0 to pi by 2 sine square x cos square x cos to the power 4x dx. What we do is we convert this into beta function. So we get beta 2 plus 1 3 by 2, 4 plus 1 5 by 2. Now we convert this beta function into gamma, that is we get gamma 3 by 2, gamma 5 by 2, gamma, add them up, 3 plus 5 is 8, 8 gamma 4. And we already learned the reduction formula and the shortcut 1 by 2 root pi, and this will be 3 by 2 into 1 by 2 into root pi. The whole divided by 3 factorial. That's it. I told you the remaining part is a homework for you. Anyway, the answer should be pi by 32. Okay, once more I will show you. Suppose you want to evaluate integral 0 to pi by 2 cos to the power 9 theta d theta. The method is very easy, my friends. 1 by 2 beta, 9 plus 1 10, 10 by 2 is 5 comma 1 by 2. And then we convert this into gamma function, gamma 5, gamma 1 by 2 by gamma 5 plus 1 by 2. And that will be 1 by 2 gamma 5, gamma 1 by 2, the whole divided by gamma 11 by 2. And that gives me 1 by 2 into 4 factorial, 4 into 3 into 2 into 1. Use the calculator, and root gamma 1 by 2 is root pi. The whole divided by 9 by 2 into 7 by 2 into 5 by 2 into 3 by 2 into 1 by 2, and then root pi. Simplify and you get the answer. But I want to teach you one more method here, which I just love, because you have two things in your syllabus. I told you. The beta gamma functions and reduction formula, and whenever we have this cos to the power 9 theta or sine to the power something, I am not talking about this product. In product, I feel beta gamma function is the best option, the best. But I am talking about integrals which will only have cos or sine, and the limit should be 0 to pi by 2. I love reduction formula because I will get the answer. We did so much and still I didn't simplify, I kept it as a homework for you. The answer will be 9, 8, 7, 6, 5, 4, 3, 2, 1. And make it fraction, okay, because this is from our reduction formula. So in case you are applying this, you can use, or you can say by using reduction formula. Anyway, whenever they ask in exam a question based on beta gamma functions, don't do this. It is better to, it's more ethical, mathematically more ethical to use the beta gamma function itself. Okay, let's move on. I'll teach you one more integral. Integral 0 to pi by 2 sine to the power 8 theta d theta. So option 1, you make it into beta function, 8 plus 1, 9 by 2 comma 1 by 2. And this gives me 1 by 2 gamma 9 by 2 gamma 1 by 2 the whole divided by gamma, 9 plus 1, 10, 10 by 2, 5. And that will be 1 by 2. The numerator becomes 7 by 2 into 5 by 2 into 3 by 2 into 1 by 2 root pi, and root pi the whole divided by 4 factorial. Okay, so that's up to you. But option number 2. So look at this and you know exactly what I'm going to do. That is reduction formula. Reduction formula is very easy. Just write 8, 7, 6, 5, 4, 3, 2, 1. And the power is even. So we end up with pi by 2. And that's it. You get the answer. Now let's do one very basic problem and wind up this video. So please write, evaluate the integral 0 to 1 x to the power 6 into root under 1 minus x square dx. I'm sure that you know what to do when you have something like this inside square root. When you have root under 1 minus x square, our savior will be x is equal to sine theta. And why I am calling that person to be our savior is, it becomes root under 1 minus sine square theta. And 1 minus sine square theta eventually becomes cos square theta, and root under cos square theta is nothing but cos theta. So here we go, we are outside the square root. And one more thing, whenever you make a substitution, you should remember two things. One is the differential, that will be cos theta d theta. And the next one, you have to change the limit. I prefer writing like this because this limit belongs to x. So it's like if x is equal to 0, then x is equal to sine theta. And that implies theta will be sine inverse x, isn't it? Yeah, so theta will be sine inverse 0. And again, if x is equal to 1, then theta will be equal to sine inverse 1, that is 90 degree, pi by 2. So we get I is equal to integral. So when x equal to 0, what should I write for theta? And here we write theta equal to pi by 2, x to the power 6. So that will be sine theta to the power 6. So sine to the power 6 theta. And this one I already showed you what happens. It becomes cos theta, and dx is right over here, cos theta d theta. Now let's simplify this and write it in the next page. So I is equal to integral 0 to pi by 2. I'll show you the previous page. Sine to the power 6 theta and cos square theta d theta. Yeah, perfect. The limits are 0 to pi by 2. That is very important. And it's a combination of sine and cos. So I don't prefer reduction formula. Anyway, whenever you have a product combination, beta gamma integral is the best. So we get 1 by 2 beta, 6 plus 1 is 7, 7 by 2, 2 plus 1 is 3, 3 by 2. And that will be 1 by 2 gamma 7 by 2, gamma 3 by 2, the whole divided by gamma 7 plus 3, 10, 10 by 2, 5. And that's equal to 1 by 2. The answer will be 5 by 2 into 3 by 2 into 1 by 2 root pi, and again 1 by 2 root pi, the whole divided by 4 factorial. That's it. You are supposed to get 5 pi by 256. So that is a small video. In the next video, we will learn how to utilize beta gamma functions, and we'll try to work out some problems, a few problems based on beta gamma function. So once more, I will show you what is that beta gamma integral. So make sure you remember this. You can note it or you can take a screenshot. And second thing, the most important points. Because once you are good with these two things, that is the definition of beta gamma integrals and the properties. If you are good with the 10 properties, then you will enjoy this chapter. Anyway, as always, if you like the video, please share and subscribe. And I'll be back soon with more beta gamma functions. So till then, my friends, bye.